Hello, my name is THAYALAN RAMASAMY and my matrix number is 078581. So first of all, I'm going to explain about our system design architecture. We start with the main process, which initializes threads, set up naming systems and triggers the replication. It interacts with two naming models, which is structured and flat naming, both resolving IPs for the nodes. Once the names are resolved, the main process starts threads for other components, including process 1 and process 2. Both interact with shared memory, which allows fast direct communication between processes by reading and writing shared data. Replication is handled in two ways. First, eventual replication, where nodes like node A and node B are updated asynchronously, good for speed, might briefly show outdated data. Second, sequential replication, where updates are logged and applied in strict order to maintain consistency. All processes are replication methods, read from and write to the shared memory, ensuring smooth coordination across the system. Now, let's dive into the shared memory model used in our simulation. Shared memory allows multiple processes to directly access data without using messages or networks. This results in fast, efficient communication within the same memory space. The core components include shared counter, which is shared data, which tracks the number accessed by all the processes. Replica state, replicas, ensuring consistent data across the nodes. Update logs, operation log, which record actions for rollback and debugging. To make testing more realistic, we introduce the simulated network delay, a small artificial lag that mimics real-world latency. This helps us to evaluate how the system performs in cloud or multi-node environments under real conditions. Together, shared memory and simulated delay create a robust and testable environment for our distributed simulation. That is all from my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Raimi Hakimi bin Muhammad and my matric number is 078717. Now I'm to present about process and thread model developer. For the first process, structure in distribute system. In the distribute system, multiply tasks to run at the same time using multi-threading. If not controlling properly, sharing data can be changed by different tasks at the same time, causing error. Reinforce log help by allowing only one process to change the data at a time, preventing conflict. Have two process 1 and process 2. The process work together to update shared data safely and correctly. Synchronization method keep the data safe to stop risk conditions where the tasks try to change data at the same time, and make sure the system stays stable. Now I'm to move to importance and benefits. It helps system work faster by allowing multiply tasks to run at the same time. It stops error by controlling access to sharing resources. It keeps a system stable by making sure process stay in sync. Using in baking on online gaming and real-time apps to protect data. A key idea for making strong and fast distribute system, help a business and applications scale efficiently while using is secure and
Assalamualaikum warahmatullahi wabarakatuh. My name is FIKRI bin MUSIR. My matric number is 078366. Okay, I will present about the naming system. This slide compares two naming model in our distributed system simulation, which is flat naming and structured naming. Flat naming uses a simple hash map for direct name to address mapping. It is fast with constant time lookup and minimal overhead, which is work well in small static system, but is lack in scalability and structure, leading to name collision as the system grows. For structured naming, model after DNS use hierarchical names like service1.university.edu. It scale well, avoid name conflict, and support delegation and better organization across the domain. Two, slightly more complex, is more flexible and fault tolerant. For the quick summary for the trade-off, flat naming is easy to implement and fast, but limited in scalability, flexibility, and fault tolerance. In contrast, structured naming supports scalable, dynamic environment with better redundancy and management at cost of added complexity. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad AMINAHAR. My matrix number 077487. Okay, so I will continue our presentation. I will take I will take this part, consistency and replication strategy. Okay, as you can see, guys, this graph that show about state rate comparison and update delay comparison. Okay, state rate comparison for eventual consistency. Okay, now have one state rate occur because each replica takes time to receive update. Okay, for sequential consistency, there is no state rates because all operations are received and processed in the same order. Okay, now we move to update delay comparison. Okay, for eventual consistency, it's like delay approximate to second between nodes A and nodes B, but still fast and scalable. Okay, for sequential consistency, there is no delay because all nodes are updated simultaneously. Okay. So next I want to talk about sequential consistency. Okay, all operations are handled in the same order on all nodes, and then there is no state rate. Okay, it has high latency, not suitable for very large or real-time system, and then it's just only suitable for financial system, banks, and so on. Okay, for eventual consistency, it replica update independently and asynchronously. It also faster update, more scalable. State rate may occur, and then it also no guarantee for same order of operation, and then it's just only suitable for social media, system lock, e-commerce, and so on. So that's all. Thank you.
Hi, Assalamualaikum. My name is Muhammad ARIF bin AZMI and metric number 078367, and I am a system integrator and tester for our distributed system project. My main responsibility is to ensure that all the main components, process management, naming system, and data consistency work smoothly together. I have tested the integration of every module developed by my team, and I am pleased to report that the system runs reliable and as intended. During testing, I observed that the multi-threading implementation is robust with no race condition and accurate data updates due to proper synchronization. The naming systems work efficiently for both flat and structured models, allowing fast and correct name resolution. Our data consistency mechanism, including both sequential and eventual consistency, function as expected, with replica reaching to the correct final state. All modules are well integrated, and our teamwork is clearly reflected in the seamless operation of the system. I have also used output data and visual to validate and communicate our system's performance. In summary, our distributed system is well integrated, reliable, and ready for further development. That's all from me. Thank you.